Okay, this is a continuation of today's lesson, and on these ones I'm going to be helping you with solving a system of equations using elimination. Okay, so this is problem number 1 on your elimination practice. When you solve a system of equations using elimination, your whole goal is to be able to add the two equations together so that when you add them, one of the variables drops out. If the equations are already set up so that when you add them, one of the variables drops out, that's awesome. But in some cases, you may have to change either one equation or both equations so that the elimination can happen. On question number 1, this one has already been set up to be able to do elimination. We have the x terms are all lined up, the y terms are all lined up, and the constants are all lined up. And when we add these two equations together, 4x plus 2x is 6x, positive 3y and negative 3y cancels, and then we have equals 10 plus negative 4, which is 6. Okay, and now from here, we have an equation that has just one variable, so we can solve for the x. We divide by 6 on both sides, x equals 1. Now, to figure out what the y is, we can go back to our first equation or our second equation, and we just use substitution. So, if I use the first equation, I write it just like it is, but instead of the x, I'm going to make a substitution. I'm going to plug in 1 for the x, because I know that x is equal to 1. And now we just solve from there. 4 times 1 is 4. 4 plus 3y equals 10. Then we subtract 4 from both sides. 3 times y equals 6. Divide by 3, and y equals 2. So that means that these two lines cross each other at 1, 2. This is the solution to the system. If we were to plug 1 in for the x and 2 in for the y, it makes both equations true. So 4 times 1 plus 3 times 2 equals 10. That's true. And 2 times 1 minus 3 times 2 equals negative 4. That's also true. This is the solution to the system. And if we were to graph these lines on the same coordinate plane, we would see that they cross at this point, 1, 2. Okay, so let's look at another one of the elimination problems on your assignment. Let's look at number 5. Okay, on number 5, you have 4 times x plus 3 times y equals negative 9. And you have 4 times x plus 6 times y equals 6. So, if we want to be able to use elimination to solve this system, we have to have a situation set up where when we add the two equations together, one of the variables will drop out. If we were to add these just like they are, 4x plus 4x would be 8x, 3y plus 6y would be 9y. Neither variable drops out. But if I were to change one of the equations so that instead of having a positive 4x here, if I can make it a negative 4x, then when I add a negative 4x and a positive 4x, that will cancel out. So I'm going to multiply the top equation by negative 1. And I'm going to multiply every single term in the equation by negative 1. And because we multiplied everything in the equation by the same thing, it keeps the equation equal. So that is a legal move in algebra. We can do that. You have to just be careful that everything gets multiplied. So now we have our new equation, negative 4x minus 3y equals 9, that we can add to our second equation. So 4x minus 3x, that's now going to cancel out. 6y minus 3y is a positive 3y, and 6 plus 9 is 15. Now from here we can solve for the y by dividing by 3 on both sides, so y equals 5. this is the y coordinate of where the two lines cross each other at. So to find the x coordinate, we use substitution. We can go back to our original first equation. We can go to our original second equation, or we can go to the equation that is our changed equation to figure out what the x is. I'm just going to go ahead and use the second equation. So I write it just like it is, but instead of the y, I'm going to replace the y with 5, because I know that the y is equal to 5. And now we can solve this equation for the x. So we had minus 30 from both sides. This would be negative 24. Divide by 4, and we get x equals negative 6. So the solution for this system is negative 6, 5. That's where these two lines cross each other at. So I'm going to go ahead and do one more of these with you. I'm going to do number 9. Okay, so on number 9, we have two equations. Remember, on all of these, you need to show all of your work. So on number 9, our two equations are negative 3x plus 8y equals negative 24. So negative 3x plus 8y equals negative 24. And we also have negative 6x plus 4y equals positive 24. In order to do elimination here, we need to pick whatever variable we want to eliminate, and then that variable needs to have coefficients that are the same, only opposite signs. So there are a few different things that we could do here. We could times the top equation by negative 2. And if we times everything in the top equation by negative 2, that would allow us to eliminate the x variable. Okay? We could also, we have the original two equations. We could also times the bottom equation by a negative 2, which would give us 12x minus 8y equals negative 48. And then our first equation was negative 3x plus 8y equals negative 24. So now when we add those two together, the y variable will drop out. Okay, so you can make a choice of whatever you think is going to be the easiest. I'm going to go ahead and just continue to solve right here for this one. So when the y variable drops out, we're left with 9x equals negative 48 plus negative 42, or 24, which is a negative 72. And then when we divide by 9, we get x equals negative 8. And then remember, to figure out what the y is, we can go back to any of the original equations or the changed equation and use substitution. So if I take this first equation, the one that we started with, and now instead of the x, I'm going to make a substitution. Everything else about the equation stays exactly the same. But instead of the x, I'm going to replace that with negative 8, because I now know that x is equal to negative 8. So negative 3 times negative 8 is positive 24. Positive 24 plus 8y equals negative 24. And then when I minus 24 from both sides, I get 8y equals negative 48. Divide by 8 to get rid of the multiplication of 8, and I get y equals negative 6. So the solution to this system, and remember this is number 9 on your today's assignment, is negative 8, negative 6.